Okay. Anybody know what the Pythagorean theorem is? Who's talking? I can't tell. Okay, Alyssa, yes. All right, so that's a formula for the Pythagorean theorem. You know what those variables stand for? You know what those variables stand for? Anyone? Anyone? Outside, what's up? Nope, not the angles. Didn't you guys like in like 5th grade or something, 4th grade, you had like a Pythagorean theorem unit? Right? 8th grade. All right, 8th grade? 8th grade it was? I was actually helping my neighbor the other day, and he was doing problems with intersecting lines and vertical angles and complementary angles and supplementary angles. I was like, we do this in high school. You guys did that in like junior high, middle school? So you guys had some of that, and then mine was like, and then when you came to my class, you're like, I've never seen this before. What are you talking about? Or you just forgot? Never seen this before. Oh, okay. All right. So when you have a right triangle, we'll call the legs A and B. And then the hypotenuse is C. Right? So what this means is if you square each leg and add them together, you're going to get the same value as if you square the hypotenuse. And we talked about those in the other unit, right? Or triangle unit. The legs are the sides that make up the right angle. The hypotenuse is the side opposite the right angle. All right. Well, what type of equation is this? Like when you think back to algebra and you see that exponent. Like we classify polynomials by their degree. When the degree is 2, it's what type of equation? Do you remember any algebra from the remote learning last year? Kelsey? That's not your hand in the air? Oh, just your split off. Okay, Josh. It's called the quadratic equation. Right. Right. When the degree is 1, it's linear. When the degree is 2, it's quadratic. Anybody remember when the degree is 3? Cubic. Right. Okay. Right. So did somebody say that or no? Yeah. I thought so. Okay, good. All right. So what we're going to do to start this unit before we get into all the Pythagorean theorem stuff is we're going to review quadratics and solving quadratic equations. So we've done some of that already, right? Like if I ask you to solve this, solve for x, and I ask you to solve this, x squared minus 3x equals 10. That's a quadratic equation. How do you solve that quadratic equation? What's up, Karen? What do I need to do? No, I'm asking you. You gotta raise your hand. I asked a question, you raise your hand, I called it. You're too late. What do you mean? Oh, it's a quadratic. Oh, so you can graph a quadratic equation, right? It's a parabola. Remember the U? It's a parabola. We graph it. Okay, but the solution is not the y-intercept. The solutions are actually the x-intercepts. You remember any of that? Okay, now there's another way to solve it besides graphing. We can do, Jasmine? Yeah, we can factor it. Okay, now before we factor it, we do what? Good, set it equal to 0. All right, so we're going to move the 10 to the other side, subtract it from both sides. Now, the reason we set it equal to 0, that's what we're finding. When you graphed that parabola last year, it's crossing the x-axis. That's when y is 0, right? So if we were graphing it, it would be y equals all that junk. And then we would graph it, and we'd see where it crosses the x-axis. Okay, well, the other way to solve it is by factoring. Now, we set it equal to 0. It's in standard form. The squared term is first, then the x term, then the number. Then we do what? How do we factor? What are we breaking this down into, Alex?
Find what adds into 3 and -3 and multiplies into -10.
Okay, before we do that, we got to start setting this stuff up, right? What,
yeah.
Do we know what multiplies the x squared?
X and x.
Okay, so we got x and x. All right, and now these two numbers, correct, are multiplying to be -10 and adding to be -3. Because what happens is when you distribute all this stuff back together, these two terms are multiplying to be this term. These two terms are multiplying to be this term. And when you distribute here and add them together, we're adding them together to get that term. So we're multiplying to be this, we're adding to be this. What'd you get, Kelsey? Okay, you get an x minus 5, and we get an x minus, what'd you say, x plus 2? Yeah, good. Right? So x times x is x squared. Then we got -5 times 2 is -10. We get a -5x, and a +2x combines to be that. Then you take your factors, x minus 5, set it equal to 0, x plus 2, set it equal to 0. So we get x equals 5 and x equals -2. All right, let's review. We've been doing that all semester, right? Okay, so that's an example of solving a quadratic equation. Another example of solving a quadratic equation is that. You guys hear that? Door slamming? No. Hearing things? Hold on. I lied. 2x squared equals 16. What can you do to solve this quadratic equation? Ramesa? Yeah, okay. We're undoing order of operations, right? We're undoing operations. Now, how come you could do that in this one and not factor? How come you have to factor this one, but this one you could just undo operations? Why? Yeah, there's only one x term, right? There's just x squared. So when there's just an x squared, undo the order of operations. Like the undoing of addition is subtraction. The undoing of multiplication is division. What's the undoing of squaring something? What's the inverse operation? Square root. Okay, right. So the first step, divide both sides by 2. We get x squared equals 8. Now, inverse operation of x squared is square root both sides. We get x equals the square root of 8. Josh, what's up? No, so like with order of operations is PEMDAS, right? That's order of operations, right? See or no? Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. Why are you staring at me like you've never seen that before? Have you seen that before? Oh, okay. I'm scared. Whew. The opposite of PEMDAS is? Yeah, SADMAP. First thing you do is try to add or subtract something to the other side. There's nothing to add or subtract. Next thing you do is try to multiply or divide something to the other side. Well, there we go. Divide by 2. The next thing we do is get rid of the exponents. Okay? Kelsey, what's up? That's what we're getting to. So on the last test, you had answers that were the square root of something, right? I said you can leave it like that. Or I said you can write the decimal, right? Well, in this unit, we're not going to leave it like that. That's not a simplified radical. Now, why? Well, on tests, you take like the SAT, that will never be one of the answer choices. The correct answer choice will be 2 square root 2. What? Where did that come from? Well, you have to simplify the radical. The square root of 8 can be simplified. Now, there's 3 conditions in order for a radical to be simplified. The first one is the radicand. Radicand is the number underneath the square root sign. This is a radical. This is a radicand. That number cannot have any perfect square factors. What's a perfect square factor? Read.
A number that multiplies to the exact number whose square root is not a decimal.
Okay, so the square root is not a decimal. So a number times itself is that number.
Yeah.
Okay, so like give me an example of a perfect square number.
4.
4. 4 is a perfect square because 2 times 2 is 4. Give me another perfect square. Karen. 144 because 12 times 12 is 144. Okay, so these are the perfect squares, right? We've got 4, 16. Wait, I forgot one. Which one did I skip? 9. Okay. Yeah, 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10. What do we got? What's next?
144.
144. 169. 49, 14. 196. 196. 59, 16. 22, 25. 16. 260? No, 3. All right, I'm done. All right. But I mean, they're never like those are really big. None of these numbers can go into this if it's simplified. Any of those numbers go into 8? 4 goes into 8. So this is not simplified. We can rewrite this as the square root of 4 times the square root of 2. 2 times 4 is 8. What's the square root of 4? Well, that's a perfect square. That's 2. So 2 square root 2. Remember when I said the answer was 2 right 2? That's how you get to that answer. So you pull out that perfect square factor. So another thing that we're going to have to look at now when simplifying or when solving quadratics is what's our answer? We need to know how to simplify that radical. Now, why would we do this? Well, I mean, why can't I just leave a square root of 8? Besides the reason I just said on a test, like an SAT, they won't just have the square root of 8. Side? No, I'm saying the number 2. 2 rad 2. Radical sign, or 2 root 2. I'm just saying the number 2 a lot. 2, 2. 2, 2. 2, 2, 2, 22, 22. What's that? What is that? It is? No, yesterday. Yesterday was 2, 2, 22. 22.
And then later it's going to be 2, 22, 22.
22, 2, 2, 2, 22, 22. It's like a commercial on the radio. Yeah. I don't know what it's for though. Is that a good advertisement if you know the number but you don't know what it's for? Like you ever watch a commercial? You're like watching the commercial. You watch the whole commercial. You're like, I don't even know what that commercial is for. Right? Side, what's up?
Apparently the 22nd of this month.
Why is that cool?
Tuesday.
So funny. Yeah, it's so like 11/11/2011. That won't happen again. Okay. Are you guys even born then? Oh yeah, you guys are.
Oh my God.
Let's get to more simplifying. Square root of 8. That one's not too bad. Ready? New directions. Simplify. We're going to simplify radicals. Now, I only gave you one parameter for a simplified radical. The radicand cannot have any perfect square factors. Okay? Should I go to number 3 or you want number 1? How do you guys want me to number? Because there's a new set of directions. Back to number 1. Simplify. Square root 27. Any of the perfect squares go into it. 4, 9, 16, 25. Any of those go into 27? What? 9. 9 times what is 27? So this is the square root of 9 times the square root of 3. We pulled out that 9 because we could take the square root of 9. Josh?
That's how we write it.
No, not yet. We got one more step. What's the square root of 9? We could take the square root of that, right? So we get 3. 3 square root 3 is that answer. All right. Now, what's up, Kieran? Yeah. That's how you'd have to write your answer. Side? Well, I mean, this is number 1. So what do you think? What do we usually do? We're going to start with this and we're going to build upon it. We're going to build our understanding and it's going to get hard. Like this. A little bit harder. And when it gets a little bit harder, I'm going to show you a different way to do it that some students like better. Hey, you should be on your phone right now because that's going to be on the. Oh, you can start. Hey, Alex, can you put the phone on?
Yeah, okay.
How's the reading on? Is it not doing all right? You know how to do all this? Are you trying to be less sarcastic?
Huh?
Are you trying to be
Less sarcastic? I'm never sarcastic. Sign, what's up? It's like when we're at home and my kid just like leaves like a mess all over the counter. I'm like, oh, Scotty, nice job. You're leaving all that for mom to clean up. That's what you should be doing. Nice. And then he looks at me like, should I clean up my mess? You know? He's probably right. Like some people don't get sarcasm, you know? So it's probably shouldn't use it.
Yeah, like mom.
Yeah. What's up? I don't know. What'd you get? What'd you get? 8 has a perfect square factor. You're not done. Okay. So look, this is what Amira did. She saw that 9 went into 72, right? So she did the square root of 9 times the square root of 8. And she got 3 square root 8. However, does 8 have a perfect square factor? We already did the square root of 8. And we already know it. So we have to go even further. Hold on, guys. I know where you're going. Right? We got to go even further. The square root of 8. We've got 3 times the square root of 8, but the square root of 8, we already know is this. 2 rad 2. So what we get is 3 times 2, 6 rad 2. That's your final answer. 2 doesn't have any perfect square factors. Now, where are we going? What's up? That's the final answer. Did you get to the final answer the same way? There's a faster, quicker way, Josh. What? It's also divisible by 4, which we can go about that whole way, but there's even a better one. Ramesa? 36. Remember the answer was 6 rad 2? Look how much easier it would have been if we knew that 36 times 2 was 72. What's the square root of 36? 6 rad 2, you get there faster. So if you could pull out the largest perfect square factor, it goes a lot faster and a lot easier. Josh. Yes. Right. So you could pull out the perfect squares and take the square root of that number. If something doesn't have a perfect square, you leave it in the square root. Correct. Like if we got an answer and it was just square root of 7, that's it. It's under there. You can't do anything about it. Right? That's your answer. Okay? Now, some people don't like this way. I'm going to show you the side. What's up?
I just want to make sure I understand.
I'm just taking the square root of 36. 6 times 6 is 36. Okay? Now, Some people don't like doing it that way. You guys know what prime factors are? Prime factors? What is that? I want to find the prime factors. Prime factorization. That's what I'm calling like the same people all period. Josh inside, Josh inside, Josh inside. Ready? Same time. Go. Okay, that number times 1, right? That's a prime number. You know, the only factors are that number and 1. So you could, some people like doing this better or more, right? This is, okay, the square, just give me any 2 numbers that multiply to be 72. Wow, very good. Nice job. Give me any 2 numbers that multiply to be 72. Bill Gunn. 12 times 6 is 72. Okay, so you just go 12 times 6. Give me 2 numbers that multiply to be 12. 6 times 2. Give me 2 numbers that multiply to be 6. 3 times 2. Are those prime factors? Not yet. 6. Give me 2 numbers that multiply to be 6. So we got 3 times 2 times 2 times 3 times 2. Those are the prime factors, right? If you multiply all that together, you get 72. Well, now you do this. You pull out the pairs. There's 2 2s. Pull it out front. Here is a pair of 3s. Pull it out front. Any numbers that are not pairs go underneath the radical sign. 2 times 3 is 6 rad 2. Ended up with the same answer. So some students like doing it that way better. We'll do another example. I'll show both ways. Okay? So you write the prime factors, you pull out the pairs. Okay? Ready? Number 3. Square root of 108. Put on the screen. Boom. Who makes this? Mountain Dew? Who makes Mountain Dew? Pepsi?
Yeah.
PepsiCo? Pepsi make Mountain Dew. Well, yeah, the company Pepsi though makes a bunch of other stuff. They make Kickstart, Mountain Dew. Like Mountain Dew makes like 3,000 different flavors now. Which one? Fanta? No, no. No, 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 I don't think so.
They did Gatorade.
No. Oh, Pepsi owns Gatorade too?
Yeah.
Oh, wow.
Because at Taco Bell, they have Gatorade.
Oh, so they have all Pepsi products?
Yeah. Yeah.
Yeah, I don't know. Damon, what's up? What'd you get? The 6 square root 3. Right. Now, which way did you do it? So 6 square root 3. Did anybody get there? 6 square root 3? You there yet? Which way did you do it? The new way? What? Prime factors? Okay, so if you do it the prime factor way, give me your first 2 numbers. So how do you know 12 and 9? How do you know that multiplied to be 108? But did you know that, or did you like use a calculator? Okay, so like if I didn't know that, right? So an easy prime factor, it's like I could just do like 2 times 54, right? And then start going that way. But you know, we know that 2 goes into it, right? But you did what now? 12 times 9? 12 times 9, and then what? 4 times 3 times 3 times 3 and 2 times 2 times 3 times 3 times 3. 2 times 2 is 4 times 2. 4 times 3 is 12. 12 times 3 is 36. 36 times 3. One way. Ooh, I said 36. Maybe that's okay. Pull out a 2. Pull out a 3. That one's all by itself. Oh, you're all by yourself. Now you get to go in there. 2 times 3 is 6. 6 rad 3. What's up, guys? Square root of 64. 8 times 8. 4 times 2 times 4 times 2, 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3 pairs. Pull them all out. 2 times 2 times 2. 2 times 2 times 2 is 8. The square root of 64 is 8. You gonna do that? That wasn't fun. The square root of 64 is 8. Why would I do that, right? You'll know your perfect squares. Yeah, so that does happen, but that's what happens when it's a perfect square number. Got it? All right. Now, let's do 3 again. Square root of 108. Different style. Ramesa.
I did 36.
Okay, if you knew that 36 went into it, this could be real quick. Square root of 36, square root of 3. 6, rad 3. Done. Now, let's do 3 again. Square root of 108. Who didn't know that 36 went into it and picked a different number? Read.
I divided it by 4, so I got 4 times square root of 4 times square root of 27, which is.
Okay, hold on, slow down. Square root of 4, square root of 27.
So that's 2 times square root of 27, but 27 has a prime factor of 9, so it's 2 times square root of 9 times square root of 3. So it's 2 times 3 times square root of 3. So it's 6 radical 3.
There you go. Just takes longer. If you don't pull out the perfect square factor, then you got to do more work. So Reed first pulled out the 4 and he got to here. But then he realized, oh shoot, 27 isn't simplified. The square root of 27 has a 9 in it. 9 times 3. 9's a perfect square. Take the square root of 9. Boom. 6 red 3, I'm sweating. What's up, Josh?
Would you say that in general,
correct. If you pick the largest one, it goes quick, right? Look at the second time we did number 3. Okay, real quick example. Watch. I mean, we're still only on. There's so much more simplifying to do. How much time? We're teaching too tired. Sweating. All right. Number 4. Right. Just real quick. If we did the square root of 600, actually, let's do the square root of 800 just to be like, because some people can pull out a 4, then they know. Okay. Square root of 800, right? I mean, that's a big number. But you like, what if I did actually? I wanted to make it. Well, that's fine. But like, watch. If you pull out like, if you only pull out a 4, right? You got the square root of 4 and the square root of 200. Okay, now I got to do the square root of 4 is 2. I still got the square root of 200. Now I got to break down the square root of 200. What if I? Oh shoot, let's do. Let's do 4 again. 4 and 50. So now I got 2 times 2, 50. Oh, I'm sweating. 4 at 50. Oh my gosh, I'm not done. 5 is a perfect square factor. 50. This becomes square root of 25, square root of 2. This becomes 4 times 5, right 2. This becomes square root of 2. Well, I do all that work, right? There's larger perfect square factor. What are those numbers going to 800? 100, right? Or even bigger. Isn't there a bigger one? There's one that I don't even have there. Kelsey? 400 goes into 800. Square root of 400, square root of 2. Square root of 400 is 20. 20 red 2. Boom, not sweating. Right? Now, 100 would have been easier than the other one. If we had the square root of 800 and we did 100, square root of 100, square root of 8. 10 red 8. Still got to do the square root of 8, though. Got to keep going. Josh? Yeah, like not that high. Like you're probably maybe pulling out a 7. Right? Maybe an 11 somewhere, right? It won't be that big. Okay. We'll do some more practice with this. Okay. But this is only the first thing that has to happen if a radical is, in order for a radical to be simplified. The radicand can't have any perfect square factors. Another rule, whenever you're solving and you get radicals, you are not allowed to have a radical in the denominator. You can't have a problem where the final answer is 6 over rad 5. There's a radical in the denominator of the fraction. Alex, this stuff's on your phone? You're watching? Are you watching me on YouTube?
Yeah.
All right. So we need to get rid of it. It's called rationalizing the denominator. Square root of 5 is an irrational number. We want to have a rational number. What the heck are you talking about? You guys remember irrational and rational numbers? What's the difference? This is like a lesson. Like really going way back. Rational, irrational. Somebody besides Side and Josh, they've been dominating this participation today. The square root of 5, if we punch it in our calculator, how many decimal spots is it? An infinite amount. It doesn't stop. That's what makes it irrational, right? If the decimal stops or repeats, that's what makes it rational. Okay, square root of 5 goes on forever. So we need to make that a rational number. What's up?
So it's rational
if you could write it as a fraction. Like a fraction has a terminating decimal.
So like 1/3 is
correct, because it repeats. Yeah, Josh.
So you can solve a problem like that by squaring them.
No, because if you square it, you're changing the value. Now, what can you multiply by something by so it doesn't change the value? 1. You can multiply anything by 1 and it doesn't change the value. Well, 1 comes in number like, what's 2 divided by 2? 2 divided by 2 is 1. What's 4 divided by 4? 1. What's 5 divided by 5? 1. Anything divided by itself is 1. What's the square root of 5 divided by the square root of 5? 1. Well, there's a square root of 5 in the denominator. If I multiply by the square root of 5 over the square root of 5, I'm multiplying that by 1. Multiply anything by 1, it doesn't change the value. 6 times the square root of 5 is 6 square root 5. Square root of 5 times the square root of 5 is what's 5 times 5? 25. So this is the square root of 25. 6 rad 5. What's the square root of 25? 5. There's no longer a radical in the denominator. So all we did was multiply the numerator and the denominator by the square root of 5. That got rid of the radical in the denominator. Let me show you again. Side. Lots of questions today, Side. I like payingattention.com.
So like
Shutup.com is a website. It is. It's a farming website. Isn't mine? I wish. I tried to get it a long time ago. I used to put it up in my homeroom all the time, and it was just a fist that was slamming down. And it said shutup.com coming soon. Now you go to shutup.com and you can buy farm equipment. What? Makes a lot of sense. Go ahead, Side.
So do we just leave radicals in the numerator?
Yeah, you can have radicals in the numerator. We had all these radicals in the numerator. Can't have them in the denominator.
That would be the
Who said why? Because Mr. Math said so. Actually, I don't know why.
Would that be our answer?
This is your answer. Yeah, done. All right, well, how do we get rid of this? For Mesa? Square root of 10. Square root of 10 over the square root of 10. Now we just got some simplifying to do. We got fractions, we got multiplying, we've got 8 square root 2 times 10, 20 over square root of 10 times the square root of 10 is the square root of 100, which is 10. Do I have to show all that work? Square root of something times square root of something is going to be the something. 10. We done? Square root of 20. Is the square root of 20 simplified? OMG. We got to simplify the square root of 20. The square root of 20 is 4 times 5, which is 2 times 2 times 5. Pull out the 2's, I get 2 rad 5. So this becomes 8 times 2 rad 5 over 10.
Or 16 rad 5 over 10.
Okay, or 16 rad 5 over 10. Now we're done. No! Oh my, 16 over 10. That's 8/5. 8 rad 5 over 5. This is fun stuff, right, Josh? Okay, what's your question? Yeah.
Browser extension that blocks spoilers.
Oh, it's not a farming website anymore?
No. It's a browser extension.
Let me see.
It's a browser extension that blocks
Shutup.com. I don't see shutup.com. I see chrome.google.com. But what if you just type in shutup.com in your browser? Type it in your browser, right at the top. Okay, that was long. Should I make you guys do a bunch of homework? All right, we're gonna. So we only got 2. There's one more thing that has to be true if radical simplified, and that is if this number underneath the radical sign is a fraction. So I'm going to teach you how to get rid of that. So tomorrow we'll review the solving quadratics. We'll review these 2 steps. We'll talk about when the radical is a quadratic, and then we're going to do a bunch of practice tomorrow. Okay? Nothing today. I'll give you an assignment for tomorrow. Okay? So we'll work on a bunch of practice in class tomorrow. We'll review this stuff, and like I said, some other things. Hey, Josh, what is it? The website. Did you put it in the browser?
yeah. You do that thing when like the website isn't real, where it's just like that a blank